Hi, welcome back to the breadboard. A few episodes ago I announced that I was going to be embarking on a CNC router project, and in the time since I made that announcement I've been collecting a whole bunch of parts. I've had some sponsored to me by RS Components out of the UK, which I showed you on a previous video, and been buying some myself as well, and had a few parts provided at a good price from some additional sponsors, which I will be linking in their details. Anyway, what I wanted to do here is just to kick off the main project by starting at the ground, almost literally. So I'm out here in my garage. I apologize if the lighting is not quite as good as it normally will be now in the lab. But you know, wherever you're going to build the CNC router or any CNC based project, where you have to start is by having a nice flat surface to stand it on, because if your surface is not even, then your output of your CNC printer, router, whatever it might be, is also not going to be even. So in order to get a flat work surface, what I'm going to do is I'm going to build one out of plywood right here. I've already been to the lumber yard, picked up some ply. I got them to cut it for me because 8x4 sheets of plywood won't fit in my vehicle, so I had them cut it down to 5 feet long and 2.5 feet wide, and I got two pieces. And the idea is I'm going to join the 2.5 foot wide pieces together to form a 5 foot by 5 foot, and that is basically what you can see here from the corner way over there to there out here. It's 5 feet by 5 feet, and the CNC, which is going to be based on these V-slot rails from Open Builds. So it's Ox Build and things like that, and again I'll link them in. They will be providing all of the main structure for the CNC router, and I have a company locally called SMB Solutions. The gentleman that runs the company, Sam, provided them at a good price for me, so that helped out a lot. And I went actually over to see him in Barrie and had a good chat, and he showed me some of his stock and some of the CNCs that he's been building and things too, so he knows the subject. So, and he's quite happy to talk to you about what your needs may be, and I'll link all the details in under the website. What I have here for the y-axis is going to be 80 by 20 V-slot rails, which is these ones here, and then the x-axis, which is this gantry. Mainly it's the gantry that goes across, is made up from two pieces of 60 by 20 V-slots and one piece of 40 by 20 set at the back to provide some additional rigidity. And these are all going to be bolted onto plates like this one. This is one of the Y-rail with the stepper motors already hooked onto it, which will actually run front to back relative to where I'm standing, and the gantry will be stringing across from here across to the other side with a 5 foot span. My only concern that I have is whether 5 feet is too much for the weight of router I'm going to put on it. So I haven't decided which router I'm going to use yet. Probably going to start out with something like a Colt, a Bosch Colt router, which is one that a lot of people use for their CNCs, and they seem to do quite well with them. The bigger ones, because I've got a the X rail basically is mounted on here, and it uses a 20 by 60 V rail going up and down. Do I have it here? Yes, I do. All right, so this is going to be used on the front for the Z axis to go up and down with the drill head on it. But the big 1.5 kilowatt router spindles that you can get from eBay in places, they're actually 80 millimeters wide, and this is only 60 millimeters wide. So I would have to build a bracket that's actually wider than the support, and I'm not sure how stable that's going to be. So what I'm going to do is I'm going to start off with probably just the Colt router, the Bosch Colt, and see how well that goes, and look at maybe doing an upgrade later on with a VHD higher performance drive, and that might involve me having to bolster the X gantry and the mounting plate for it, so that I can have a stronger support for the drill. Anyway, I don't want to make this intro video too long, so one of the things I wanted to explain for this is that you've got your base here. It needs to be stable and flat, like I said. It doesn't have to be level necessarily, but if it is level, like with a spirit level to gravity, then obviously your X and Y system is going to move much easier because you're not going to be fighting uphill and downhill. But the key here is that it is flat. And then what I'm going to build mine with is this 3/4 inch thick plywood. And I'm not going to, I was debating whether to make it into a torsion box, but I don't think I'm necessarily going to need that because the table underneath here was built originally. I built it a few years ago for use as a woodworking workbench, and I really didn't use it too much. So I've taken the top off, but it's made out of 6 inch by 6 inch pine legs, and it's very, very heavy duty and very, very solid. So I'm going to mount the table on top of that, and I'm going to have some plywood, probably about 4 inches deep at least, running around the perimeter of the table, which will provide some extensive stiffening in the overall structure of it. And I may put a little bit underneath, but not make it into a full torsion box. And the reason for that is that, plywood, you're basically paying about $50–$60 a sheet for 8x4 plywood, and I've already got 2 here, and I've got plenty of excess, so I can actually do a partial torsion box around the bottom just for the outer perimeter, which would make it very, very rigid. And that's where the weight of the CNC is going to be as well, because as you can see here, the 8x20 sits on top of the 60x20 rails. So there's actually no weight in the middle of the table except for the workpieces that you're going to put down. So it doesn't have to be ultra strong from a weight perspective. It just needs to be flat and fairly rigid. And because I've got the table that is sitting in the middle, that's going to add a lot of rigidity to it. And if I put these extensions out underneath with the plywood, then that's going to extend that rigidity out to the extreme edges and provide an additional bit of stability. And I'll video the process when I start doing that, just so you can see it. And then on top of that all, once the table is flat, I'm going to be screwing down the front and rear 60x20s, and then there's going to be some longitudinal bars running across to the back as well, which is going to add even more rigidity to it. So overall, by the time we're done, it should be pretty solid. And one of the things that's going to happen here, if I just mount these on just for a moment so I can show you, is the rail. This is actually going to be the wrong way around for this side, but nevertheless, it'll demonstrate what I mean. So these rails will run along here, okay, with a GT3 belt, and it's going to have a pinion on the end of the router. So this is going to be able to drive, and there's going to be one on both sides so that they drive together in the Y direction. And then I'm going to take this back off because otherwise it's going to fall over. And then for the gantry, like I said, we're using this plate, and the stepper mode is going to be coming through here on the top, and there's going to be a belt going XY as well. And this is going to be sitting on this rail, the double rail, which is a 60x20. So it's, the 80x20 is going to be very, very stiff. It can take a huge amount of weight in the middle without any notable flexing. The 60x20s, even though the router itself is going to be loaded on here, it's actually got 2 in parallel of 60x20s. So it's going to have overall more stiffness than the 80x20 on its own. And this is the one that's going to be running across the router, the CNC router table, like this, using, again, the GT3 pulleys and gears to drive it across. And it should be able to get some reasonably good speed, and it's going to be quite stiff. And then the last part, which is the Z-axis, is going to be using this 8mm ball screw, which is going to be down here. Now, right now this is about 15 inches long, so I'm going to be cutting it down to the required length. And the idea is I'm going to give it probably about 12 inches of potential travel, because I want to be able to bring it to the front of the table so that I could put maybe some work in a vertical position as well, and work on some end grain or some different shaped pieces. That's a thought. I haven't figured it all out yet, because with the router you lose, with these plates, this is for the right hand side, you actually lose a little bit of positioning because of the motor and the guide rails and everything else. And the drill head, or the work head, is quite a way in front of the gantry. So if you can get it to come right to the end and maybe have a notch in the table, then you could have some vertical work surfaces that you could be milling against as well. The other thing I want to be able to do with this, of course, is cutting fabrics and various other things. Like my daughter is in the fashion business, so she wants to be able to put out big patterns and things and cut them out on the table. So that's probably going to be changing the router head for a laser cutter or a drag knife or something to do that, which would also, of course, be able to handle foam and cardboard and various other lightweight materials. And then the other thing I want to be able to do with it is to put a PCB mill on. Now, obviously, I'm not going to do PCBs 4 feet by 4 feet, which is the design size for the work area I want to have on this. They're only going to be smaller, a few inches by a few inches. So what I would do is I'd probably just position it off to one side and have that as the work area. And then on the back here right now, it's bare wood right now, bare wall. I'm going to put a large sheet of plywood on the back, and what's going to be up there is the control system. So I'm going to have an industrial computer up on the wall. The electronics with the stepper motor controls and things like that are all going to be mounted up on the back out of the way, and I'm going to have flexible track that's going to be running it down the side to bring the cables up onto the CNC router, and then one on the gantry to allow the remaining cables to get up to the work head here. So anyway, that's all the various bits and pieces that I have. I'm going to ultimately put a complete parts list together so that if you want to build one yourself while we're doing this, then you can. And the main thing I think that changes for these CNC routers, I'm doing 5 feet by 5 feet. If you wanted to do one that just did 2 foot by 3 feet, or 12 inches by 24 inches, or something smaller, the only thing that really changes is the length of the V-rail that you get. These kits from Open Builds, the main head and everything else would remain the same. You can get smaller stepper motors as well. Instead, if you're going to do a small 12-inch by 24-inch, say, an example, or an 18 by 18, then you really don't need to have 475-ounce NEMA 23 stepper motors. You can go for the cheaper NEMA 23s, or you can even go down to NEMA 17s if you're just going to have a small Dremel kind of work head doing all the cutting and things on smaller pieces of wood and plastics and stuff. So you can bring the cost down quite considerably, because obviously the bigger stepper motors and the bigger drill head you have are going to be a lot more expensive. And that's one of the reasons why I haven't bought my drill head yet, because something like a Bosch Colt I can pick up in Canada for about $150. And that would just bolt right on here with a mounting bracket and things, and away I go. But if I go to eBay even and pick up one of the 1.5 kilowatt high-speed spindles, they're going to cost me $450, $500 at least to get a decent one. And it is possible that my gantry may not be strong enough to even hold it. And I certainly will have to probably cut some new front plates for mounting it and everything else at minimum, even if it is strong enough. So I want to be able to have the ability to cut those plates out myself, because even buying these plates already cut out and everything off of eBay is still a little under a couple of $100 for these. Now, they're high-grade aluminum, they're well-made and everything, but if you can get the aluminum yourself and you have the ability to cut them out, then you can save yourself quite a bit of money. It's kind of like chicken and egg, though. If you don't have a CNC to do the accurate cutting out, and you're not geared up with the tools to do it by hand in your workshop, then you really, you need a CNC to cut out the parts to make your CNC. But of course, once I've got this one up and running, I'm going to be able to make my own. So if I do want to make this a little bigger so that it can support a heavier duty router spindle, then all I've got to do is cut out a new pair of plates here. The side plates are probably already going to be strong enough, and it's just a case of bolstering the gantry X-axis plates to be able to do that, and maybe add a couple extra wheels in here for more support and things. The other part that is the one thing that's a little harder to find is when you get your Z-axis ball screw, try and make sure you get all of the parts from the same place. For the bearings, I actually got the 8mm ball screw from the same gentleman in Ontario that sells the V-rail here locally, but he didn't have any bearings for me, so I had to end up ordering some more 8mm inside diameter, 16mm outside diameter bearings to get this mounted on my Z-rail, as well as the collets and adapter for the stepper motor. One of the things that Open Builds actually has on their website is a complete Z-axis kit, which has everything, and all you do is you just need to bolt it straight to your X-axis gantry and you're done. So it's worthwhile considering that when you're looking at buying all your parts. Otherwise, you may have to shop around a bit and order from a number of different places to get everything you need. The other thing you need a lot of is M5 screws, different lengths, because there's lots of bolting things together, both in the T-slots with angle brackets, with the wheels and everything else. So a lot of places I've seen that are selling the wheels on eBay or from Open Builds, they are selling, either they don't sell the screws with them, in which case that's fine, you're not paying for what you're not going to use, or in my case they sent me 25mm screws with the wheels, and they wouldn't fit right through the 1/4-inch plates through the wheels and the spacers and everything else, and have enough room on the end for the nuts to go on. So I had to actually get some nuts and bolts from the local hardware store to enable me to build those parts up together. Now, fortunately, I was able to use a lot of the 25mm screws that were now redundant from the wheels with other parts of the project, even if I had to cut them down a little bit. So they didn't totally go to waste. And I think the last point on when you're buying these bits and pieces, especially with the nuts and bolts and stuff like that, is see if you can find somewhere that you can buy them from in bulk. Because if you go to, like in Canada, Home Depot, if you buy them one at a time, you're going to probably be paying close to $1 for each screw, or 50 cents for each screw that you buy. If you go to a store like Fastenal, which is another one that's in Ontario, it's more for industry and everything else, then you can get a box of 100 screws for about $10, which means it's about 1/10 of the price. And yes, you'll end up with a bunch of extra ones that you don't need or that are spares for future projects, but you're still not spending any more money, but you're getting yourself covered. And you may even end up saving yourself some money for some of the sizes, because you're going to need so many of them. Anyway, I think that's pretty much it for kicking this off. The next video is going to be probably assembling the table, so I'm going to try and keep these into short, concise videos for each part of the build, so that you don't have to sit through an hour every single time. So table build, getting it level, and gluing it together and everything, joining the 2.5 pieces of plywood together. The next bit will be assembling the frame, the X and Y gantries, and getting some of the electronics set up and things like that. So I've already did a quick review of a lot of the electronics from my lab on a few videos ago, but I will be, as I build some of these things up, I will be taking it into the lab and demonstrating things like how the stepper motors work, how do the controllers work, how do you interface the controller to your PC, and various things like that. And those ones I'm going to do predominantly in the lab, not out here in the garage, because, well, we're just about to go into winter and it's going to get quite chilly out here, for one. Plus, I've got all of my other test equipment and everything else down there, so it'll be a little easier to demonstrate some of the basics. But as I assemble it, I'll be bringing the camera back out here into the garage and setting it up on the actual CNC router table and everything else. And I hope that within the next month to 2 months, we'll have this all up and running, and we'll actually be able to start making stuff. So in the meantime, there's going to be lots of tutorials, lots of how-tos, theory behind stepper motor control, spindle control, and all that kind of stuff that, you know, if you're new to this, you really need to know the basics. Now, I'm not going to go into theory of magnetics or anything else. It's more going to be like I did with the power supply project, where it's a practical, how do you use these pieces? What do you need to know to pick the right part? And what do you need to know to make it work efficiently and well with your computer and things like that? It's, so I don't want to go into the philosophy behind it or it's a practical tutorial set that we're doing here. It's not a theoretical. The theory is about, I've got which stepper motor do I want? How do I drive a stepper motor from a stepper motor controller, from an Arduino, from a Raspberry Pi, from a PC, stuff like that. It's not about anything lower level detail or more in depth, unless it is pertinent and important. The next video, I'm going to clear the table off and we're going to build the table up and get it nice and flat, ready to start receiving all of the rails and everything. So anyway, if you like the videos and you're interested and you've got some ideas of what I should be doing or what you'd like to see as we go through this project, put it in the comments, send me an email, whatever you prefer. And if you're new to my channel, subscribe if you're interested in following along, and you'll get automatic updates as we go. Radio spares in the UK has been, I keep calling them radio spares, goes back to my childhood when I started out as a teenager and they were called radio spares. RS Components has been very generous to me and sent me pretty much all of the electronics that I need for this, with the exception of the actual spindle itself, and they just don't sell them. That's why they can't provide one. All of the other electronics they sent me from the UK, and it's quite a lot, and stepper motors, controllers, power supplies, DIN rails, everything I need to wire it up except for the wire, basically. And I probably will just get that from the local store and everything as we go. And they even sent me connectors and things too. So I am very, very grateful to RS Components for all of that. And you'll see I'll be posting a lot of the content for this tutorial set onto the RS Components community website, as well as my own web channel. Anyway, that's it for now. And I'll be back very soon with the first part, putting the table together.